Okay, so let me share the screen. So in further, we'll continue with functions in this session, and this is lesson 4. Okay, and the next topic we'll cover for today is object-oriented programming concepts. Okay, so we'll go into functions, and I've rearranged a little bit here, added all these things here, which was not there in the earlier Excel set. So today's topics are like we'll look at basic functions. These are some star args and star keyword args. It's a part of functions. Then we look at recursive function and some other concepts like memoization and so on. Okay, so let's move on. Are you seeing my screen? You are, right? Okay.
Yes.
Okay. So we start with functions here. Okay. So what are functions? Now, functions are block of code. Block of code like we did now, currently the calculation of tax calculation, or we also did some scoring and grading. These are lines of code. So when you have to do them individually, you can write them in a program, but the block of code together can be given a name. Okay, so that name is called function. Okay, so we define the function with the def keyword. Okay, so the def keyword like here, def Fahrenheit to Celsius. So def is how the standard keyword is for defining a function, and then followed by one space and the name of the function. Okay, functions have optionally an argument. Okay, so this is within brackets here. In this case, temperature. So I've put some temp here. This can be any name, it doesn't matter. Okay, and this is an argument. Okay, an argument. Again, so that argument is passed into the function when we are calling it. Okay, so to call this function, we'll call the name of the function and pass a value. Okay, and the value can be anything. Okay, so here 32, and it is passed in. Now what this function does is it is returning some value. After converting Fahrenheit to Celsius, it is returning a value. So when you want the function to return a value, you use the return keyword. Okay, so the return statement or return, these are keywords, def and return are keywords. And this return is also optional. Okay, a function mostly will have a return value. Okay, and that value is substituted when the function is called here. Okay. So these two lines are just the definition of the function. Of course, this is the formula for converting. Don't have to bother about the specifics of the formula, but what is happening here is temp is passed here in this formula, and then the calculated value is going to be returned. Okay, so that's how a function with a return value is. And when you have to call this function, we can call it inside a print function. This is a built-in function by itself. So print freezing point is comma. You can call inside this built-in function your function. Okay, so Fahrenheit to Celsius, and value passed is 32, comma, and the string, later part of the string. So degree Celsius. So when I call this function, I could call it in multiple ways. Here is an example. Print freezing point of water. Okay, Fahrenheit to Celsius 32, comma C. So then the freezing point of water is 0 degrees Celsius. Boiling point of water at 212. So it converts it to Celsius and says boiling point of water is 100 degrees Celsius. So functions allow you to block certain line of code and give it a name. Okay. So when we define the function, so there are two, if you observe carefully, there are a couple of things. One is the definition of the function, def followed by keyword. The very next line should be at 4-character spaces indented. Okay, in Python, the indentation is what they follow, and this colon at the end of the definition. So these are syntax, colon at the end of the function name, and 4-character spaces in the following line preceding the statement. So in this case, return. So there is no need to put any brackets. Unlike Java, they'll use some flower brackets, or there is no such convention. So this is just the way it will understand this function has certain lines of code under it. Okay, so that's the definition of the function right there. So this definition is over. This is a call. Now this parameter here, uh, within brackets, while defining, it is actually the name, the notation or the calling is like here, this is called parameter. But when the function is actually called with at the time of passing the value, this is called an argument. Okay, so the naming convention, I'm just familiarizing you. This is a parameter, this is an argument. Okay, while defining, the parameter is defined like so, and of course there is a calculation in this case. While calling, the function is given an argument. Okay, all right. Is this clear?
Yes.
Okay, so let's move on. Function have default arguments. Okay, so of course here the parameters, there are two parameters, a comma b. So you could have any number of parameters, there is no restriction. So def add is just adding, I mean, it's the name of the function, it's adding two values. So return a plus b. So you have the value return whatever you will call it with. So now print add 5,7 is going to return the value a plus b, and it will return the value 12. Okay. Now, let's say, now this same program name, I want to pass another value. Okay. So there are 3 values here, but I have written only for 2 parameters, right? So when you're passing 3 arguments, Python will give a typical error called type error. Add, which is our function name, takes 2 positional arguments, but 3 were passed. Okay, so this is how an error will crop up, because it has been defined with only two parameters. Of course, then what we have to do is we create another function of the same name. Yes, it will allow, Python will allow addition, creating a new function of the same name with now 3 arguments or 3 parameters here. Okay, and return a plus b plus c. So then what happens? Now I can pass either 2 arguments or 3 arguments, both will be accepted. Okay, so this what we have done here is we have overloaded the function. Okay, that means same function name we got. Once again the function is defined, but now it has got a different signature. Okay, this is called sometimes called signature, or different number of parameters. And look here, what's happening here is the third parameter c equal to 0. Okay, c equal to 0. Okay, so suppose I don't pass c, c will automatically take the value 0. So this is, we are defaulting the function. Okay, we are defaulting the function. Here now if we add 1 comma 2 comma 3, if you have the values in the argument, it will take the values. But if you don't pass a value, it is going to default to c equal to 0. So is this clear?
Yes.
Okay. So like I said, this A, B, C can be any values. It can be a string, it can be a number. There is no definition of these uh, parameters. Okay. So literally Python will let you take Boolean, everything like that. Okay. Now in this, let's go to the collab session. Yeah, you can also open the notebook. So here is def add a comma b. Just watch initially. Okay. Keep the notebook there. I'll give you some time. So def a comma b. Okay, that is added. So I'm running a print. So it'll print both of them. Add 5 comma 7. It's 12, 9, 12 and 9. It's 21. Okay. Now here is def welcome. So when you log into okay, def welcome here is not having any arguments, any parameters. So I said this parameter is optional. It's just returning some message. Welcome to my Python bootcamp. Okay, so if I just run that, so it's just going to print that. Now, when let's say you're developing a web application where you want to welcome every individual who is joining, right? Who is logging in. Okay. So then you want to make this welcome message dynamic. Okay. So then I have welcome within brackets student. Okay. So now I'm returning hi student plus a welcome message. So this is going to allow you to dynamically create a function. So that's an argument where I'm creating a student. So here is a call to that welcome function. While logging in, I'm sending the user name or the student name here. Hi Sriram, welcome to my Python book. So this is a function with an argument. Sriram is the value it is taking. Okay. Normally, when you log into your own application, so such welcome messages can be created. So is this clear?
Yes.
Okay. Can you try at your end? Yeah, just open a notebook and you can refer my screen here. Okay.
It says my program is running, but it doesn't show any output.
You please share your screen. Let me just guide you there. Stop sharing now.
Oh, I see what it is. I found it.
Okay.
It's working.
Okay. So this should have a space below, and this colon is sometimes people miss this uh, at the end of the function. And that's why I'm giving some time for you to try.
The code would
Okay. So add is you created add and you're able to print the output.
yes.
Okay, very good, very good. How about this welcome?
I'm entering.
Yeah, okay. Okay, Sriram. Well, let's go on to check all this. Okay, so functions. So here is function with the third argument. Okay, so c equal to 0. So we have defaulted here. Okay, and then I'm saying add. So these three values 100, 200, 300. If the value is passed, it will take. But if the value is not passed, it's going to default to 0. Okay. If we don't default and we pass only 2, it will give an error. Okay. So that's why we pass a default. We initialize a default, and the way to do that is in the definition itself, c equal to 0 right here when you define the parameter. You can try that. You got that,
Yes.
Okay, very good. So now if you see, I can add more arguments in the call, but what will happen is it could land up uh, me going and defining every time the function definition in multiple ways, right? So again, another version of the function with the same name with fourth argument, fifth argument. I cannot go on adding like that to keep the function in a way that it can accept any number of arguments. Okay, so let's get back to this deck. Yeah. So in order to keep the function have a dynamic number of arguments or any number of arguments, you use this star args. So star args is syntax. Okay, it means that your function's parameters, when you define inside the bracket as star args, Python will accept any number of arguments. Okay, when you call the program, it will accept any number of arguments. Is that clear? So
Yes.
let's see the example. So here is 400, and this will typically error, but here is a definition, star args. Okay, so star args, now I'm initializing a result of 0. Okay, and for I in star args, okay, so I have to add, or my objective here is to add all these values. So I'm just wanting to pick the first value, add to this result, pick the next value, add to the result, and so on, and finally return the result. So to do that, I'm using a for loop for I in args. So you can use this args, args, inside a for loop, okay? And the result is, so I takes the value of the entire args, one at a time. So I takes the first time, the first value 100, adds to the result like that, then second run of the loop, I takes the value 200, adds it, and so on. Okay, so we are looping through each element here or each parameter here, and each argument what you pass at the time of the call will be substituted against this args. When you're defining the function, the syntax is like star args here, but inside you can just use args. Okay. Now, once that is done, return result. So this is a function definition with star args. Okay. Once that is done, now here is a call. I have 5 arguments. It runs, it's the result. Okay. And it can be any number of arguments. So here is about 9 arguments. The value is there. Okay. So the function is often in Python, you will see the star args because users don't want to restrict, or developers don't want to restrict to a fixed number of arguments or even defaulting it and all that. So simply, you don't have to bother what you will pass in the arguments. You can directly define the function, the name within brackets, args, I mean star args, okay? And then do the calculation, go about looping through like this. Now here for result, the result, these 2 lines will run, and then finally out of the loop, line 5 return the result. Is this clear?
Yes.
Okay. So yeah, you can try at your end. Yeah. Define this same function with star args. You can share your screen. If you are hitting some errors, I will guide you. Yeah. Okay. Okay. It's working. Yeah, you can go like 10, 20, likewise, no problem. Okay, any number of arguments. Okay, very good, very good. Okay, so now inside function definitions, the first star args is one of the arguments. You might sometimes encounter star keyword args. This is when we use keyword which are name value pairs. Okay, sometimes you have to pass data to the function in terms of a key and value pairs. So in such occasion, the function should also be able to take a key value pair. So that's when you will define it with double star keyword args. So that's the syntax for accepting a name value pair. Later we'll see that it is called a dictionary. Okay, a dictionary is a key value pair. We'll look at it later. But this notation of function having star args, comma, star keyword args is going to make the function accept any value. Okay, here is an example. Let me just, okay, this, we looked at this example for the star args. Here is another example for the keyword args. Now, what we are seeing here is def connect. Okay, a simple example for connecting. This is a function which is accepting keyword args. Okay, and we are not doing anything more than just printing keyword args. Okay, printing what we are passing. Now, here is how a dictionary looks like. So keyword args means this is a special kind of data you are trying to connect to a server. So here is the name, and a name which is a key here. Okay, the key and its value. So when you're connecting to a server, in this case, local host, which is your own machine, uh, server is a key, colon, local host. Okay, so key and a value. So servers have some port. So port is the next key, colon, the value. And between the first key value pair, there's a comma and the next key value pair. Okay. So third one, username, password. Typically when you connect, a username and password is required. So user is another key, its value is root. Password is another key, its value is like that. And this entire list of values within flower brackets, this is curly braces, also called flower brackets. So within flower brackets is equal to your configuration. Okay, or some, so this configuration is what I'll pass. So this configuration is what I'm passing when I call this function. Okay, the function here is called, and when I'm passing this particular configuration, again, I'm passing star star config. Okay, and the output of the program will look like that, because we just print what is being passed directly. Okay, so this config will get printed as a string like that with the brackets. Okay, the config will get printed as a string with the brackets. So this whole thing is called a dictionary, much like the dictionary in English. Okay, so in the dictionary in English has what you have a word and its meaning, right? So the word is on the left in a dictionary, the meaning is on the right. Okay, so same way, key and a value. Okay, and the whole thing in code, whenever you notice this flower bracket and this key values separated by comma, it's called a dictionary. Okay, so I will, how do you identify a dictionary, you might ask. So whenever you see this way, this is a dictionary with the flower bracket. When we did a list, the square bracket is a list. Okay, so these are some advanced data types in Python. We'll come to dictionary a little later. But in this example, the reference here is to use uh, double star keyword args, which can accept key value of any dictionary. Okay, it can accept a dictionary. So, so often when you are writing Python programs, you will see this notation. Okay, here is, okay, I'm just showing the same here. So you will see this notation uh, with keyword args. Okay. The first argument would be star args. The second argument would be double star keyword args. So both are defined by developers to say that I don't have to bother how many arguments I'm going to receive for this function. I don't bother about whether the function can have one, or it can also have some data sent to it at the dictionary. So the common practice is to define a function star args, comma, star star keyword args. Okay, that signature for the parameters will be there in many functions. Okay, so a developer does not have to bother whether it's a specific set of parameters at all. Okay, so that's the example for keyword args. You can try at your end, Sriram. And please, yeah, you want to refer here? That's fine. Yeah, I'll leave it this open. I can pass this through the chat. See, like that. Did you get the output?
Yes.
Okay, so let's move on. Uh, Here, next we have what's called, yeah, so there it gave the output. Okay, so yeah, the next topic is we see recursive functions. So whenever you have to do some operations repeatedly, we know we can give a certain block of code a name which can be called. But what are recursive functions? Recursive functions are functions which call itself. Okay, so functions which are repeatedly called. Okay, meaning you could call that function uh, within that function. Okay, recursivity means I define a function and then I have the block of codes, but uh, inside the function I'll call the same function. Let's look at an example. Okay. So finding a factorial of a number. So let's say I want to write a function which takes an input of a number n, say 7, and it calculates the factorial of 7. The factorial of 7, if you see, is 7 into 6, 5, 4, till like 1, like that. Okay, so this would be a very large number, right? But what's happening here is factorial of 7 is 7 into factorial of 6, right? So fact 7 is factorial of 7 into factorial of 6. Likewise, fact 6 is again 6 into factorial of 5. Likewise, you can just go till factorial of 1. Okay. Now, this is a case where the same function is called several times repeatedly. Okay. How many times? I'm calling it 6 times here at least. Okay. So recursive nature is the function calling itself. Okay. So factorial of n is factorial of n minus 1. Okay. So factorial of n at the bottom of your screen is equal to n into factorial of n minus 1. Pardon me. Factorial of n is equal to n into factorial of n minus 1 recursively. So that's what we call it as a recursive function. Now, let's see a certain part of code for here. Okay. So def factorial, you can give it any name. So I'm giving it factorial within brackets x. Okay. So factorial of 1 is 1. So when x takes the value, I return 1. Okay. No calculation, no recursivity. When factorial of 1 is straight return a value of 1. If factorial is the past number x is anything greater than 1, it will come to this else part and return x into factorial of x minus 1. So see this in the definition itself, factorial is called once again inside recursive. Okay. So this will call again, go in and call like that. You get factorial of 7 in this case. So this is called a recursive call. Is this clear? Sriram, is this clear?
Yes.
So result here is factorial of num and the so input it's taking a number. So let's go to the code here. So I do have a function written here. If it is equal to x, return 1, else x into factorial 1, x minus 1. Then I'm passing a number n, or I could take it as an input. Either way is fine. Call to factorial of num. So this will make the recursive call, and then I print the factorial of 7 is the result. Okay, so let's go. Okay, here it's prompting me, but I've already given some initial value. Let's take the same value, 7. The factorial of 7 is 50, 40, like that. So this was a recursive call. Okay. You want to try at your end? Here it does not have to have 2 values. So the program, I'll just pass the value. Let me just send this through the chat. Over here, num could be 7 or any entered value. I put it in the chat in the interest of time. Did you get the output, Sira?
Yes.
Can we move on? Okay, so next one. This is another way to calculate the factorial. We have a different program here. Okay. It uses a match case condition. Okay. We will come to it, but here is what match case is. I've just passed the function definition with n being the number to which you're going to calculate the factorial, but match n means when n, when it's like saying when values n, case of 0 and 1. Okay, so case of 0 and 1 means for 0. Okay, likewise. Okay, case of underscore means case of anything else. So in Python, underscore is typically the discarded value, but here when it used inside a case underscore means case or anything else. So this is like the else. Return the recursive function call. So this is with the match case. Unlike in the last example, we did if, no, if and else. This is match case. Match n colon in case something colon 0. This is pipe symbol 0 or 1. Okay, read it as 0 or 1. So 0 or 1, factorial of 0 is 1, right? So 0 or 1, return 1. Case else, colon, the factorial call. And now for that function, I'm making a call like I in range of 6, print I factorial, you'll get this output. 0, 1, 1, 1, 2, 2, 3, 6, like that. Okay. So we're printing each time the factorial call. This is another example with the match case. Okay. All right. Yeah, we'll look at the match case also another in later on. Okay. Memoization. Now, memoization means what? Okay, it's not a typo. Okay, it's not memorization, but it is close enough. Okay, memoization, written MEMOIZATIOA. Yeah, memoization means take in the last case, we had taken case 0 or 1, it's just return 1. So then for 0 and 1, we are not going recursively and making a call to factorial of 1 and factorial of 0. Instead, we are straight off returning a value 1. Okay. So, and since this is a recursive call, you're calling the same function again and again inside one another multiple times, right? So then let me come back here. Step 1 to step 7, the lower part of all this need not go through some recursive calls. Like step 7 here is directly 1. I don't have to put in the calculation fact 1 and then go to 0 and all that. So the lower half of this recursive call, if you do not call this factorial, instead of not calling the factorial, if you keep some constants in memory and return it, or your program is directly picking some value and calling, it is that number of factorial calls lesser. I repeat, the later part of it, if it is memorized, instead of recursive calls, let's say factorial of 1, factorial of 0, those are all not recursive calls. So the program will run faster, right? So the later part of these calls, if you are memorizing, programs going to be more efficient because it's not repeatedly calling the same number of times. So as many times we are going and keeping, let's say 2 factorial I know is 2, okay? 3 factorial is 6. So if I keep lower part of it more in memory, the program's efficiency, the performance will be better. Okay. So that is what is called memoization. It's memorization in terms of programming. Okay. So how do we do memoization? Memoization simply means remembering, okay, or memorization applied to programming. So memoization, results of values are remembered instead of recalculation. Results of values are directly remembered, then we call the program is memoized. Okay. Now, how do we do this? When you write this, take for example, Fibonacci. Okay, like I said, factorial of 1, factorial 0 is stored in memory and make the program run faster. But here is another example. We are looking at a Fibonacci number. Okay, hope you know the Fibonacci number is like adding two last numbers. Okay, so the definition of that is also a recursive call. So Fibonacci of n, the formula is Fibonacci of the last two numbers. So Fibonacci of n minus 1 plus Fibonacci of n minus 2. So here these last two numbers are making my function call itself twice. Okay. So if in one calculation itself it's called twice, it's going to be even more uh, affecting performance, right? So then when you write such a function, all you have to do is at memoize. Okay. This is the way you give um, a decorator. This is called a decorator. Okay. But what we are doing, when you put at, you use memoize, then the function will automatically adjust to remembering values which need not be recalculated. Okay, so that's the way it works. So when you say Fibonacci, you have a larger calculation. Okay, so what is happening here? If n is less than 2, return n. N is less than 2. We look at Fibonacci numbers. Hold on. Let me just switch here. So here is Fibonacci numbers. 1, Fibonacci of 1 is 1. Fib of 2 is also 1. And 1 plus 1 is 2. So that means fib 3 is this. Okay, fib 3 is the third Fibonacci number, has a value 2. How did it get the value 2? It took the previous two Fibonacci numbers and added and got 2. Okay, so then fib 4 is 3. How did you get 3? 3 n minus 2, I mean n minus 1 and n minus 2 are 2 and 1. So 2 plus 1 is 3. So 5, you go like that. So this is a Fibonacci series. I have listed out all the Fibonacci numbers. Okay, 1 to 10. So then fib 10 is fib 9 plus fib 8. Okay, fib 10 is 30, fib 9 is 34, fib 8 is 21, 34 plus 21 is 55. Is this clear?
Yeah.
Okay, so then all we are doing is we're calculating like this, Fibonacci, this is the definition Fibonacci. If n takes less than 2, it's n. N takes 2 less than 2, it's the value of n is n itself. Okay, so less than 2, it is 1 only. Okay, I could just say return 1. That's 1 here. In fact, in less than 3. So the more you park into memory, so that's memoization. So let's define the Fibonacci function here, and you got 89. Okay, fib 10, fib 110 will take a long time. Fib 10, 55. Okay, so we're getting fib 10 is 55, fib 9, and so on. So this is also a recursive function, but here we are we can use memoize. Okay, so let me send this. Uh, okay, I'll put it in the chat. Please try at your end. So I'm stopping the sharing one moment. You can share at your end. Okay, so what was that your you can change the values of Fibonacci. Yeah, give a function called different. Yeah, all right. Okay, so that's okay. Let's get back to the Excel. Okay, let me present.
Ajit sir,
Uh,
for the Fibonacci sequence, without telling it like previously how the Fibonacci sequence works, how can it just know that this is the Fibonacci sequence? Does it have a built-in thing where as soon as I say Fibonacci, like define Fibonacci, it understands that it is the Fibonacci sequence and it runs the program? Is that how that works?
no.
How
We
do
yeah. It's actually it's easy to miss that. Let me explain once again. No issues. Let me share the screen. Are you seeing my screen?
no.
No. Just give me one moment. Went into okay. I think did you see this one? Fib
Yeah, yes,
any
yes.
function call. That's why I put it as Fibo. Okay. Uh,
Yes.
Here that's to just explain the concept. Simply Fibonacci of a I mean, this is my function call, but what it does in reality is it will go 10 minus 1 and 10 minus 2. So we are making a function called the last two values. Fib of 10, if you see the last two values are 20, 34 and 21. Okay, that's how Fibonacci is. Okay, Fibonacci is a recursive function where, unlike factorial, where it called once, here when you go call the last n minus 1 and n minus 2, you'll get the answer. Okay, so it's not because I've defined it Fibonacci. If I call it any name, okay, uh, Fib, okay, the same name I'm to call twice. It's a recursive call. Okay. And I'm calling that here. So my definition is, okay, let me even take this out, and this is a call. Okay. This is my definition, a recursive function definition. Pass a value, its previous two values, it will calculate. Okay. It will calculate the previous two values, and what it does, it takes 9 and 10. And if I pass fib 9, it will take 8 and 7. Okay, so fib 9 is what? 34. So fib 9, I put 34. What it does, fib is fib 8 and 7. What is fib 8? Again, fib 8 is 7 plus. So it will go recursively doing this. So these two lines of code only is Fibonacci's functionality. It will go backward at each step, much like the factorial. At each step, it will do two additions. Okay, it will do two additions. In this case, it is returning fib 8 and fib 9. Does it know the value fib 8 and for fib 10, fib 9 and fib 8? Does it know? It doesn't know. Again, it will go call recursively what is fib 9. That is the way this works. Is this clear?
Yes, but
Yeah.
for memoization, how does this correlate with memoization?
Memoization here, it can store the lower values. Okay, so I mean, if you got the recursive call, that's good. For memoization, you will have to define it with the at memoize. Okay, uh, Python does that. It knows to remember the constant values, the lower values. That's what it does. I mean, keep memoization, like when you find it, you will see that it will take that lower values as constant. Okay. Although in this case, we are not applying memoize, but memoization means you can park some values at the lower end without calculating uh, the recursive nature. So if you say less than 2 is 1, no? So 1 is that. The memoization will have a decorator called memoize at the top of the function, like I showed. But in this case, it may not be, it's typically like this, memoize, okay? But here we are not having too much of storing in memory. But whenever you see this memoize, it means that some of the recursive nature is not there to recall from memory. Okay. Though in this case it may not be a better example, but I just put it to showcase that these two values, less than 2 is only one value. It's not a great example of memoization, but the lower value is not going to be calculated for memoize. Okay.
Okay, thank you. Thank you.
Though we are not, why I took fib is because the same function is called twice. Okay, so it's just to tell that, look, there is a lot of calculation going on for every call. So the lower values could be stored, and there, in this case, it's only one. So maybe this is not a good example of memoirs. Okay. The lower examples where we are having more such lesser calculation, if it's less than 5 or so each time, let's say if it's less than 3, then two values can be stored without calculating. So that's where it can have a memoize. Okay. Right. So yeah, I mean, just understand the concept that when you see anything which has memoize, it can be like you are not doing the recursive call. Okay. Right. Okay, so let's move on. Is that clear?
Yes.
Okay. Uh, so this completed, of course, this is painting done in Python language. Okay, it's done by me, but this is art drawn, generated with some libraries like NumPy and Matplot. It's like plotting libraries done to create real art. Okay. Okay, Sriram, Have a good day. Yeah. Thank you.
You too. Have a good. Bye.
Thank you.